So how do we now check who won and who lost? Well, for that, we need to basically check the health values, the player and the monster health. That is what matters to us here. And hence, we could add if checks here after we attacked the player. So after both the monster and the player got attacked, here we could check if this player health is smaller than 0, in which case the player lost. And we could check if maybe also the monster health is below 0, and so on. But we would have to repeat this check. We would have to repeat this check in the special attack monster function and also in the heal player function. Because maybe we healed ourselves, but the monster still dealt too much damage and we still died. So repeating the same code in all those places, that's not what I want to do, because repeating code is never good. If we ever decide to change something, we need to change it in a lot of different places, and therefore we want to avoid that. Instead, with View, we have a nicer way of keeping track of something and then doing something in reaction to that. We could add a watcher. So I'm going to add watchers here by adding the watch option to the configuration object. And here I want to watch two properties, the player health and the monster health. So we add a watcher for the player health property. And as you learned, this name is now not up to you. Instead, that has to be the name of a property you want to watch. And here I want to watch this player health property. And hence I'll also add a second watcher where I watch the monster health, like this. You also learned that we get the values then of those watched values whenever the watcher triggers. And therefore, let's now start in the player health watcher. There we need a regular if check where we check if the value, so the player health, is smaller or equal than 0, and if, let's say, the monster health also is smaller or equal than 0. In that case, we would have a draw, because both participants are below 0. Now, another case would be if just the value is smaller or equal than 0. So the first condition is not met, but the value, so the player health, is below 0 or equal to 0. Then we know the player lost. We don't need to check the monster health being smaller than 0 here, because we're going to do this in the monster health watcher. There, indeed, I want to check if the value, so now the monster health, is smaller or equal than 0, and if the player health is smaller or equal than 0. In this case, as mentioned, we have a draw. Or else if just the value of the monster is smaller than 0, then the monster lost. Now, of course, I am aware that if we take the monster below 0 and it then hits us and takes us below 0, both watchers fire because both healths changed, and therefore these if checks run twice and we'll find out that we have a draw twice. This won't be a problem, however, because you will see what we do with this information. We're just going to show something on the screen and it will only show up once there. So finding out that we have a draw twice will not be a problem. What do we want to do if we have a draw then, or when the player lost, or the monster lost? Well, we probably should display some message on the screen. And for that, let's go to the index.html file. And here, above the controls, but below the health bar sections, I'll add a new section now. Give that section a class of container, which will just give it some default styling. And now inside of that section, I want to say game over, and then either say you lost, or you won, or it's a draw, and also present a button to start a new game. And that screams for what? For VIF, because now we have conditional content. First of all, this entire container with the game over message should only be shown if the game really is over. So if we either have a winner or a draw. And then the message below that, something like you lost in a h3 tag, or you won, or it's a draw, those h3 tags should also be shown conditionally depending on who won or who lost. And therefore we need to not only check those values, but also change something which we can then reflect in the HTML code. And that again screams for a data property. Here we could store the winner and initially set this to null, because initially when the game starts we have no winner, of course. But then here, if we have a draw, I want to set this winner equal to draw, let's say. So to a string that says draw. If the player lost, I want to set this winner equal to monster, because the player lost, the monster won. Here it's this winner, which is a draw again. And if the monster lost, this winner, of course, is equal to the player. So now we have the winner data property, which is either null, or if it's not null, holds a string of draw, monster, or player. And we can use that in conjunction with if to conditionally show this entire game over container, but then also the different messages. The entire container can be shown with if indeed winner is truthy. By default, at the beginning, it's null, and that is treated as a falsy value in JavaScript. So if I set if winner and winner is null, this section will not show up because null is interpreted as false. If it is a string like draw or monster or player, the concrete value does not matter, then this is truthy and therefore this section does show up. Now inside of the section we also need if, here on the h3 elements. I want to show you lost if winner is equal to monster. Else if, and for that we can use the else if directive, I want to show the second h3 tag if winner is equal to player, because if the player won, I want to show you won. And last but not least, with else, we can show it's a draw. We could also use else if to check if winner is equal to draw, but since we know that we only have those three options, I can also just use else. With that added, if we now reload, you see initially we have nothing here. By the way, when the game loads, you briefly see that other content show up until the Vue framework is downloaded. That is something we'll also tackle later in the course. Later we'll have a different setup where this initial flickering is not visible, just as a side note. But here, that is our starting setup now. And now let's try to end the game. And let's see who's going to win. Okay, looks like we lost. The health bars are not reflecting this because they basically don't go into the negative, they don't reach 0, but we see the you lost message. Now let's reload and let's try to win. So for that, we need to use the special attack and also heal ourselves a little bit here. Special attack, attack, heal ourselves maybe, special attack, and we won. And let's see if we can achieve a draw here. I'm not sure. Well, I won again. Here it is, I was able to achieve a draw as well. So this seems to work, we're showing the proper message here. Now let's make sure we also do restart the game thereafter if we do have such a draw. And let's maybe also update the health bar correctly to really have an empty health bar if the game is over. I want to start with the empty health bars, and for that we have our computed properties with the bar styles, right? Well, we could change those a little bit and tweak them to make sure that we set our bar widths to exactly 0% if the game is over. That should be fairly easy to do here, because we can check if this monster health, in the monster bar styles, if monster health is smaller than 0. If that's the case, I want to return an object where the width is set to 0%, so that we set it exactly to 0. A negative value can't be displayed, so we need to set it to exactly 0. And only otherwise I return the dynamically calculated health. And we can do the same here, check the player health, the player health. If it's smaller than 0, then I want to return width of 0% and otherwise return the actual value. With that, if I reload and I quickly try to end the game, you see now my health bar is empty now that I lost. And if I try to win here real quick, you see now the monster health is 0. So that seems to work. Now for restarting the game. We could add a button in our game over box below the H3 tags. A simple button like this, where we say start new game. Now this button should do what the name implies. It should start a new game when clicked. For that, of course, we need a method, because we need a new action which we can trigger from inside our HTML code. Hence, I'll add a new method here. The position of the method does not matter, by the way. You can add it at the end, in between, or at the beginning. And I'll just add it here because start game sounds like it should be at the beginning. And in here, I now essentially want to reset all those parameters. So player health, monster health, current round, and winner. This should all be reset when we start a new game. So therefore, we can set the player health back to 100, set the monster health back to 100, set the winner back to null because we have no winner, and of course also set the current round back to 0 because we start a new game again. And now it's start game that should be triggered when this button here is clicked. So we simply add a click listener as we did it many times before and point at start game. And if we now save that and reload, let's give it a try. Let's try to end this game here and see who wins. It's a draw, but we have start new game. And if I click this, you see the health bars update and a new game begins. So this is working here. Let's now also see if we can lose. Yes, and this all works. So now we got this start new game functionality as well. We got the game working therefore, but the surrender button is missing when we want to, well, surrender. And the battle log is missing. A log which I want to have at the bottom of the page, which simply shows every action that happened. So every damage dealt, every health point healed, that should show up here. And I'll implement the surrender button right away in this lecture already, because it will be super easy. If we add a new surrender method, which we of course need to be able to do anything when that button is pressed, I want to set the winner equal to monster, because if the player surrenders, the monster won. Alternatively, we could also set the player health to a negative value, but I don't want to do that here. I don't want to kill the player with, well, by setting the health to 0 or something like that. The player simply surrenders. So we just set the winner to monster and we're good. And now we can go back to index.html, and on that surrender button, we bind it with a click listener to the newly added surrender method, just like that. If we now save that and reload, if I click surrender, I can start a new game. One thing, however, is not ideal. Even if I surrender, I can still press attack and the health bars still update. So we might want to disable all those game action buttons if the game is over, or remove the controls entirely if the game is over. And that's actually something I will do here to finish this lecture. We do show this game over container if we do have a winner with VIF. Now this section is a direct neighbor of this section. So here we could make sure that this only shows up if we don't have a winner with not winner, so if winner is falsy, or since it is a direct neighbor, by using VElse, so that we only have those game controls if we don't have a winner yet. And if we do have a winner, we'll not have the game controls. So if I save that again and I surrender, now the game controls are gone and I have to start a new game to bring them back. And the same happens if we lose the game naturally. The game controls are gone and we have to start a new game. And with that, I think the core game functionality is finished now, and next we can work on that battle log. Again, as always, feel free to implement something on your own there. We'll do it together in the next lecture. So let's move on to the battle log. And there are certainly many ways of implementing such a log. I want to have a log where we can add messages that basically keep track of which action occurred and who started this action and which value was connected to this action. For example, how much damage was dealt. For that, we should go back to app.js and add a new method here, which could be called addLogMessage because that is what we're going to do. This method should take 3 parameters. It should take the information who did something. So I'm going to name it who. Then I want to know what happened. Did we attack? Did we heal? So I'm going to add a what here. And I need to know the value. How much damage was dealt? How much did we heal for? So these are the 3 parameters we need here. Who, what, and value. And with this information, I want to add a new log message to a growing list of log messages, which then can be output here in this battle log on the screen. Hence, what do we need? A data property, an array of log messages, which can change and which view tracks to be aware of changes so that it updates the UI when it changed. So therefore here, I'm going to add a log messages array, which is empty initially, and whilst we're at it, we can also already reset it to an empty array when we start a new game. So set log messages back to an empty array here. But now that we got log messages, in add log message, I want to add a new log message to this array whenever this method is called. And I want to add it at the beginning of the array so that the latest message is always right on top. So it's the first one in the array. And we can do this by reaching out to log messages and using unshift. Unshift is basically like push, but where push adds something at the end of the array, unshift adds something at the beginning of the array. And now it's up to you how a log message should look like. Thus far in the course, in the other lectures and modules, when we worked with lists and arrays and v-for, we always had arrays full of strings, full of text. Here, since we have 3 pieces of information that matter, I will actually add an object to this array. So a log message is an object. And you will see how we can output this on the screen in just a second. So here, I will now add different pieces of information to this object, the who, what, and value to be precise. And I'll name the key action by who, action type what, and action value, the value we got. So we add an object to our log messages, which has 3 keys, action by, action type, and action value, so that we know who did the action, which kind of action it was, and what the value of the action was. That's how we add log messages. And now a new log message should be added when we, for example, attack the monster. So here in attack monster, before the monster attacks us, I want to call add log message, so this newly added method, and set the who to player, because the player attacked the monster, want to set the action to attack, and pass in the attack value, like this. Now, when the monster attacks us here in attack player, I also want to add a log message, but now it's the monster who attacked us for this given attack value, which we derive here as well. Of course, we do the same for the special attack. Here, the player attacks the monster. We could also name this special attack, but that's really up to you how you want to handle those different types later. I will not differentiate between special attack and regular attack, so I will just name it attack here as well. If you would want to add such a differentiation, you could use a different identifier here, but I'll stick to attack. And last but not least, for healing here, the player heals himself for the heal value. So that is the log message I want to add here. So now we got these different log messages being added. With that, our log messages array will grow. And now the question is how we output those messages. In index.html, we got this unordered list here in our battle log. And this unordered list should render a bunch of list items. As I mentioned before, you don't need to use a list item to use v-for. v-for can be used on any element. But since we're outputting lists of data and we want to write semantically correct code, often you will use v-for on list items because that is the semantically correct HTML element, well, for list items. That's just a side note. The more important thing, of course, here is that we use v-for though. A nice view directive we learned about, which can help us with outputting list content. It allows us to repeat this list item element and create it as often as needed to have one list item HTML element on the screen per item in our log messages array. So therefore here we need to refer to log messages and go through it with the in keyword and then get access to every single log message, which we now can use on and inside of this repeated list item. And now here, the content we want to output, of course, is fully up to you. We could use interpolation here to output the action by field, which is one of the 3 fields we add as a log message, which basically indicates who did something. Then we could add a dash and a new piece of interpolation here to output log message action type so that we know what happened. And then another dash and another piece of interpolation here to output our action value. That's something we could do. With that, we would output who did something, what happened, and which value was associated. And if we save that and reload, indeed you will see if I click attack here, we have these 2 log messages where we see that the player attacked for 6 and thereafter the monster attacked for 8. And that's a nice start, but actually I prepared some styles to output this in a nicer way. So let's actually use those. And therefore I'm going to get rid of that and instead add a span here, a span element, which actually should hold the initiator of the action. So this action by field. So here I want to access log message and check if action by is equal to player, in which case I want to print player here with a capital P. Otherwise it'll be the monster, so I'll then output that. So a little ternary expression here. I also want to have a second span thereafter, which holds the type of action that happened. And here we either dealt damage or we healed ourselves. So with vif, I'm going to check if log message action type is equal to heal, in which case here I want to say heals himself, so that we say something like player heals himself for, and then of course the amount of healing done, which I'll wrap in another span simply so that I can later add some styling to highlight the value. And into this second span here I'll add the log message action value, which is the amount for which we healed here. And I'll give this span here a CSS class of log-heal, which is one of the prepared CSS classes here, to simply color the amount by which we healed green. That's the only reason why I have this extra span here, so that I can add an extra CSS class just to this heal value text. Now this was one option. I need another span next to this general heals himself span, and that is for the scenario that we actually dealt damage, that we did not heal ourselves. Here we can use VLs because dealing damage is the only other option we have in this game, and therefore here I'll say attacks, so that we say something like player attacks, and deals. And now again output the damage in a span so that we can add an extra CSS class. In this case the log-damage class, which is a prepared CSS class to give it a red color. And output the damage value again in that special span so that we take advantage of this highlighting of this special CSS style. So here we have log message.action value again. So this is now how we could structure this. I also want to add a CSS class here to this first class to highlight who did something. And for that, I'll dynamically add a class here because I want to add different classes depending on whether we have the player or the monster doing something here. So I'll add this object syntax here and add a class of log-player, which is another prepared class here, this one, if action by is the player, and add log-monster if the action was started by the monster. You need single quotes around those keys here, by the way, since we're in a JavaScript object here, and dashes in property names are not allowed without wrapping the whole property name into quotes. With quotes, though, they are allowed. So that's why you need single quotes around your property names here. And the values of these properties here, as you learned, need to be values that indicate whether or not those classes should be added to that span. So you need true or false here in the end. And therefore we can simply check if log message action by is equal to player here. If that is true, I want to add the log player class. If that's false, I don't want to add it. And for adding log monster, I want to check if log message action by is equal to monster. And of course, only one of the two will be true at a given time. And that's my logic here. Now, this is quite long, but outsourcing this into a computed property would actually not really be possible because this does not depend on some general data property, but on a concrete value we get for this exact list item which is being rendered. So if you would want to outsource this into JavaScript code, you would indeed need to use a method to which you pass log message action by, for example, because that is not a single value managed application wide, but that depends on which list item is being rendered. That's just a side note. With that, however, if we save that and reload, if we now attack, we see something like monster attacks and deals 12, player attacks and deals 6. If we heal, we see player heals himself for 9, and thereafter the monster attacked us for 13, so that didn't help too much. This now looks better, and so on. So this all seems to work. Now we got a log, and if the game is over, we can inspect the whole log. If we start a new game, it's of course reset as it should be, because in start game, we set the log messages to an empty array again. And that is the finished game here. That actually is a nice first project, which shows all the core features we learned about, like interpolation, vbind, von, different events, methods, computed, watch, vif, v4. It's all in here, and therefore I hope that this project helps you get a better understanding of Vue, the different pieces that make up Vue, and how they all work together. Now we're really well prepared to dive deeper into Vue. Knowing the basics about Vue, which we do by now, is of course important. It's the most important part. But in my opinion, it's also important that you understand what Vue does behind the scenes, how it works behind the scenes. And that is exactly what we're going to explore in this module. Now, I will say this module is optional, at least the majority of it. There are 3 lectures which you should not skip: the lecture about refs and the 2 lectures about the Vue app lifecycle. You can skip the rest of the module for now if you're not interested, though I strongly recommend that you don't skip it, or you at least come back later, but you will definitely get the most out of this course if you go through this module right now. I mean, after all, that is why I did add it at this point of time in the course. Because having that extra behind the scenes knowledge will help you overall as a Vue developer. Because if you understand the tool you're working with, you're able to work with it better. Specifically in this module, we will explore how Vue works under the hood, how its reactivity system works under the hood, and we'll also understand how it uses a concept called the virtual DOM to efficiently update what you see on the screen. Now for this module, I prepared another very simple project for you. You find it attached. And there I already have a simple Vue app created with Create App, where we have 2 pieces of data, the current user input and a message, where we have 2 methods, one to change the current user input to the event target value, and one to set the current message to the current user input. And all of that is connected to some HTML code. That is the section we're controlling with Vue. This is what triggers the save input method. Here we trigger the set text method, and here we output the message. And then we got some styles, which we of course can ignore, though these are largely the styles you already know anyways. Now, this app here is very simple. Vue is awesome is something I can enter here, and if I click set text, that's the message showing up here, and that is achieved with a combination of data, methods, and then of course event bindings that trigger the methods, and interpolation to output the message data. Now that's all something you'll learn about in this course, and I'm not going to bore you by repeating this again here. If that is still unclear, you should go through the previous lectures and modules again. Now what I want to explore here is how Vue does this behind the scenes, this automatic updating here. If we change the text here and set it, this part of the page we as a user see is updated by Vue. And that's this built-in reactivity which Vue has, which is one of its core features. Essentially, Vue does one important thing. The data you define here is something Vue keeps track of. I mentioned before that it would take this data object here and merge all your properties in here into a global behind the scenes managed object, the same object where your methods are merged into, by the way. And indeed, this is what is happening behind the scenes by Vue. It also does other things like ensuring that this points at this global object. But when it comes to the data, the important and key thing which Vue does is it turns your data object into a reactive data object by essentially wrapping your properties with a JavaScript feature called proxies. In JavaScript, there's a built-in feature, which is called proxy, which Vue leverages under the hood to wrap your properties here and to be notified whenever you assign a new value, like here with message. When I set a new value to message, no matter if that is another data property or a hard-coded string like this, no matter what it is, when you assign a new value to message, Vue is made aware of that. And that's important. If Vue would not be notified about this new assignment, it could not go ahead and update what you see on the screen. It needs to be notified by changes like this so that it recognizes that it should scan the controlled HTML code for usages of that changed property, like here, message is being used here. And then when it sees those usages and it knows that message changed, it goes out to the rendered page, to the screen the user sees, it goes to that screen and finds the appropriate place there where this dynamic content is displayed and updates it there on the screen as well. And that's this built-in reactivity which Vue does and uses behind the scenes. Now, how does that work though? I mentioned that a feature called proxies would be used. Let's explore that in greater detail. For a second, I will leave Vue to dive into that proxy thing which is built into JavaScript, which Vue uses. And let's leave the Vue world here and write some vanilla JavaScript. We have a variable message where I say hello. So this is a regular JavaScript variable. It has nothing to do with Vue. Now, the interesting thing about JavaScript is that if I now have a new long message, which is my old message plus, let's say, world, I can of course console log that here, and we would see hello world. If I save that, open the console, and reload, we see hello world here. Now that shouldn't be too surprising. But now if we change the message thereafter to hello and a couple of exclamation marks, if I console log long message again and I reload, I still get hello world. I don't get all these exclamation marks here. Instead, I just have one exclamation mark after hello. Because JavaScript by default is not reactive. That is really just something which Vue adds for us. JavaScript by default is not reactive. If we have a calculation like we have it here, where we use a variable and we change that variable thereafter, that calculation here is not re-executed. JavaScript doesn't note that message changed and that it was used here. So that is how JavaScript works. And Vue works differently. Vue has a built-in mechanism to be aware when message changed so that parts of the app that rely on message can be updated. And as mentioned, for that it uses proxies. So let's see how proxies could work. For that, let me remove that and let's create an object, data, which is just an empty JavaScript object, again, not related to Vue. And let's put the message in here. Hello. Now we can wrap this object with a proxy in JavaScript by creating a new proxy. And that is a constructor function built into modern JavaScript. Therefore, make sure you're testing this code in a modern browser like Chrome. Now we can store that proxy in a constant, and this proxy wants the object it should wrap, in this case, data. But it does not just want this. Instead, it wants a second object as a second argument, and that will be an object full of handlers for that wrapped object. Now I'll come back to what that is in a second. Let's first of all create such a handler object here. This handler object can now use certain features. It can set up so-called traps, which proxies support. For example, set traps. You do this by adding a set function here in the handler, and as an argument, you will automatically receive a target, a key, and a value. Now, to understand what this does, let's console log target, key, and value here. And let's now pass this handler object as a second argument to our proxy. Now I said that the proxy would wrap this object, this data object, the first argument, and indeed it does. So on the proxy, we can indeed access message just as if we would have a message property on the created proxy object. Because actually we will. It wraps this data object, this object has a message, so the proxy also has one. And we can set this to hello with a couple of exclamation marks. Now let's save and reload. And what you should see here is that you get 3 console log messages because we have 3 console logs here. The first one, the target, is essentially the object that was wrapped here. That's just your object that was wrapped. The second one, the key, is the property that you just set a new value to. And the third one, the value, is the value that was set. And that hopefully shows you what a handler does. With that, we can define a setter function, which is triggered whenever a property is set to a new value on this proxy. And then we can find out which property that is, what the new value is, and which original object we wrapped. And we could then use this if we had another property here. Let's say a long message, which initially is hello world. But we want to ensure that long message changes if message changed. Let's say that's our goal. Now, by using a proxy and setting up such a handler with a so-called set trap, we can implement this. We can check if the key we're setting is message. So if we're setting the message property, and if we do, we want to set target long message equal to the new value we assigned for message plus world. And thereafter, we also want to make sure that the message property itself is set, so we set target message equal to value. And the interesting thing can now be seen if we console log proxy.long message thereafter here at the end, after setting the message to hello with multiple exclamation marks and after updating our handler here. If we now reload, we see that down there from line 40, we're outputting the long message, which now picks up all those extra exclamation marks. So long message was updated when we set message. So here we built our own reactive system for tracking one property and updating another property when that one property, the message property here, changed. And in a nutshell, and of course with a couple of simplifications, that is what Vue does under the hood. It keeps track of all your data properties here, and whenever such a property changes, it updates the part of your app where that property was used. For example, it knows that it needs to update this paragraph where you're using the message. And it does that by wrapping your properties with proxies so that it has a chance of finding out when you're setting a new value. That is how Vue works. And of course, it has a way more complex way of doing that than I did it down there. And of course, it also has computed properties and watchers which are triggered when a property changes. But that's just the in a nutshell approach, which hopefully gives you an idea of how Vue works under the hood, so that this magic, which Vue adds and which is amazing, is a bit less magic in a positive way. Now that we explored reactivity, I already want to leave it. I already want to leave this example because that really is all I think we should know for now of how Vue's reactivity works under the hood. It's not all we should know about Vue in general, though. For example, you might have wondered if you can only have one Vue app per page. And maybe you already tried out working with multiple apps, because yes, you can have multiple apps. Here, and thus far in all the lectures and modules, we just haven't had one app. and we mounted that to one part of our HTML code, which would then be controlled by that app. But you can absolutely have more than one app if you wanted to. So if we add a second section here with an ID of app2, we can absolutely create a second app, maybe name it app2 here, with view create app, which we mount to this app2 ID section. And in here, we can do the exact same thing as we did in our first app. We can also return a data object here. We can have a data property here, like a favorite meal, pizza. And we can then, of course, output this here in our second app, the favorite meal. If we do all of that and save that and reload, here is our second app. Now it's missing the styling because I actually set the styling up to target the app ID. But if we would target the app2 ID as well, we would get the exact same styling as before. So if you quickly find all the places in the styled CSS file where we target the app ID selector, simply add the app2 ID selector with a comma as well. Also here. And here. And of course also for the input, if you plan on using one in your second app, and all the other styles. Now, since I don't use a button and so on in my second app, I'll omit this. And with that, if I reload, we see this in a nicer style. Now, of course, you can't use data from another app. So here in my app 2, in this section, which is controlled by the second app, I can't output the message, which is part of the data of the first app. This does not work. If I do that, you see nothing here, because message is not a data property of the second app. It's one of the first app. And these two apps have no connection, which is important, by the way. Each Vue app works standalone. There is no connection between them. These are really two different parts of your HTML code controlled by two different apps with no connection between the apps. So this here does not work because this is the data from another app. And therefore, multiple Vue apps are definitely something you might want to use if you have different independent parts on your screen that should be controlled by Vue. If you have a part that needs to work together though, for example, an input which is connected to the button which ultimately influences what's in the paragraph, if you have that, then this all should be controlled by the same app, of course. So we can have multiple apps, and I already mentioned that we control different parts of the HTML code. Now, of course, it should be needless to say that you shouldn't control the same HTML part with different apps. And you also can't use one app to control multiple HTML parts. It's one HTML part per app. And also the term HTML part or controlled HTML is not entirely correct, though I used it because I think it's easy to understand. The official term is template. By mounting your app, your Vue app, to a certain place in the DOM, in the HTML code, you make that part of the HTML code the template of that Vue app. So this section is the template of our first Vue app, which is mounted with this selector to this section. And that other section is the template of our second Vue app. And I'm emphasizing this because we're also going to hear about the term template later again. There also are different ways of defining your template of an app. This here is definitely the most common and most convenient one. Writing HTML code and then mounting your application to it, this makes a lot of sense. But actually, it's not the only way of adding a template. And I want to show this here at the example of app 2. You can also add a template to a Vue app by adding the template option to your app configuration object. This template option wants a string. And to write multi-line strings with ease, I will use backticks here. Really just so that I can write multi-line code. So these are not single quotes, that's a backtick, which is a different character on your keyboard. And now we could, for example, grab this paragraph here and cut it from the HTML file and instead add it in this string here. This now is the template of this second app. And actually this was the template before as well. We controlled this section, so anything inside of the section was our template. Now I'm just defining this differently. Now we still need to mount this app, because Vue still needs to know where to display this template with the actual value for favorite meal when it is rendered on the screen. So we still need to mount it, otherwise Vue wouldn't know where to add this paragraph on the page. But with that, if I saved it and reload, you'll see the same output as before. The template is just defined differently. Now in reality, you will most often use the approach we used thus far. We get nicer syntax highlighting there, it's easier to understand, and there is no great reason for using this string-based template. We will, however, learn about a different way of defining a template and of writing Vue code in general in a couple of modules. Not a drastic change, but a nicer way of doing that. So that's also why I'm emphasizing this template part right now already. For the moment, just be aware of this template concept, and that of course there's nothing wrong with the approach we used before, but that with that approach, we in the end made all the content of the Vue-controlled HTML part the template of that app that controlled that part. Now here's a lecture which I recommend that you do not skip in this module, because I'm going to show you a different way of getting a value out of such an input element. Thus far, we're listening to the input event, and therefore with every keystroke, save input is fired, and in the save input method, I in the end just save the current value of the input to the current user input data property, so that we can eventually use that property later to assign the entered value to our message. Alternatively, as you learned before, we could also use vModel and bind that to our current user input property like this. That is also something you learned about in the course before. Then we can omit this input binding here. But whatever approach we use, we basically log what the user enters with every keystroke. Sometimes that is what you need. For example, because you want to validate the user input with every keystroke. But sometimes that's also just overkill. And in such cases, Vue has a feature that allows you to retrieve values from DOM elements when you need them instead of all the time. And that feature is called refs. Here's how you add it. Instead of adding this event listener, which you still could add in addition, but which we simply won't need anymore now, instead of having that, you add a special attribute to this element, the ref attribute. Just like the key attribute, which we used with v4 before, the ref attribute is a non-default HTML attribute, so the browser doesn't know it, but Vue understands it. You assign a value here, which is any string identifier of your choice. For example, user text. But again, this is totally up to you. And you can also not just add refs to input elements, you can add them to any HTML element, to paragraphs, headers, sections, inputs, text areas, whatever you need. Now, why am I doing that? Because Vue detects such refs and stores them internally. It basically memorizes that you want access to the input element. And in the JavaScript code, you can then get this access. Here, in this case, inside of the setText method, because that's where I need the entered value. Instead of using this approach, I can now set this message equal to this, and now a special property which is provided by Vue, the $refs property. $refs is a property provided by Vue. All Vue provided properties start with $signs to make it clear that this is a built-in property. This is an object full of key value pairs where the keys are the ref identifiers you set up in your template, for example, user text. So here we can access .userText. And this now simply points at the DOM object for this input element. So the JavaScript object we can use in vanilla JavaScript as well when we got access to a DOM element. So now here we can get access to the full input element. And to show you what this means, I'll comment this out and log it to the console for now. If we now open this console and reload, and then click set text, you see the whole input element is logged here. And if we use console dir instead of console log, and click set text again after reloading, here is the inspectable object. And this is really the JavaScript object representation of this input element with all the properties that has. So this is not Vue specific, that is the vanilla JavaScript object we could use and work with in any JavaScript code. And for example here, we got this value property. Essentially, the object we're logging here is the same one we get access to with event target, which is why we can access value there as well. But now we're not doing this with every keystroke, but instead only when set text is emitted, which happens when this button, the set text button, is clicked. So now we can access value here, and with that, if we reload, and I set the text to Vue is awesome and click set text, this works as before, but now we're not logging the input with every keystroke, but we only extract it with help of that refs feature when we need it. And that's why refs is a feature worth knowing and why you shouldn't skip this lecture. Now we already learned about a couple of nice behind the scenes and core features of Vue. Let's now understand how it actually updates what we see on the screen. Of course, we learned about its built-in reactivity, but this is basically just how Vue detects that an update is needed and where the update is needed. But performing that update in a performance-optimized way is yet another thing. And I mentioned this before and I'm going to show it to you again. If I inspect an element here in the browser developer tools, you will notice that if I type here and I click set text, only the paragraph with the text inside of it flashed here on the right. So Vue only updated this paragraph and nothing else on the screen. And Vue does that with a concept called the virtual DOM. So how does that work and why does Vue update the DOM like this? We got our Vue instance, our Vue app, and we got the DOM, the browser DOM, so the HTML content rendered by the browser, and therefore essentially what the user is able to see on the screen. Our Vue app, our Vue instance, stores data, computed properties and methods, and the browser DOM is then influenced with help of that Vue-controlled template. That template content is rendered to the DOM, and during that rendering process which Vue controls, the dynamic parts and placeholders, the interpolations and bindings are removed, and the actual values are inserted. I mean, that is what you can see here as well. We got the paragraph tag with the test text being rendered here. We don't have the curly braces here, yet we of course do have them here in our template. On the button, we got this add click thing, which is an instruction to Vue, and that's why we don't see it in the actual DOM that's rendered in the browser, because those Vue instructions are removed by Vue when it renders its template to the DOM. So when it basically converts its template to the actual HTML elements that should be shown on the screen. That's what Vue does here. And therefore, if we have data like this, we see something like this on the screen instead, if we use interpolation for outputting the data, for example. Now, of course, our data and our computed properties might change. For example, because the user entered something or clicked a button. And those updates should of course be reflected, but Vue should not re-render the entire page every time something changes, but only the parts that did change. Because if Vue would re-evaluate and re-render the entire page, well, that would not be great for performance if just one piece of text changed. For example, if just the title changed, but not the text property here, then only the h2 tag which outputs the title should be updated, and not the paragraph. Now, how could Vue ensure that this is the case, that it does not re-render the entire screen? Well, one possible solution would be that it basically compares the old DOM values with the new ones. So it basically goes through the entire rendered DOM, sees which content is in there, and compares that to the content it has stored in the data properties of the Vue app. And if there's a difference, it updates it. Well, it could do that, and at least it would not update the entire screen then, but actually it's not what it does, because reading the entire real DOM, which is rendered by the browser, all the time whenever something changes, is also pretty performance intensive. Maybe not as bad as re-rendering the entire page all the time, but definitely not great. Instead, as mentioned before, Vue uses a concept called the virtual DOM. It basically has a virtual copy of the real DOM, which is managed entirely in JavaScript and therefore in memory. It could look something like this: a bunch of JavaScript objects where Vue memorizes which HTML tag is needed and what the content of that tag is. And when data changes, it basically just creates a new virtual DOM, you could say, and compares the new virtual DOM to the old virtual DOM, and only differences between those two virtual DOMs are written to the real DOM. And that is way more efficient, because doing such comparisons and updates in a virtual DOM, and therefore entirely in memory, is way more efficient than doing it in the real DOM, which was rendered to the screen. And that's how Vue does that behind the scenes. Whenever we change something, whenever I change this text here, and I click Set Text, Vue detects this change thanks to the reactivity we discussed earlier in this module, and then it creates a new virtual DOM, compares it to the old virtual DOM, and detects the differences, and then updates the part in the real DOM where the differences were detected. That is what Vue does in a nutshell. Now, it should be needless to say that Vue has a bunch of optimizations in place that actually make this way more performant. In reality, it does not recreate entire virtual DOMs all the time. It has a bunch of optimizations for that. But this is beyond the scope of this course, and really also not something you need to know necessarily. You should just know how it generally works to be aware of what Vue does, that it's not all magic, but that it's pretty performant.